This is the lecture video for section 6.3. Here is the video 3. We're going to be talking about solving equations using reverse direction of the double angle identity. So the example we have here is example 4. We want to solve 2 times cosine squared theta minus 2 times sine squared theta plus 1 equal to 0. And we want the answer to be in both interval 0 to 360 degree and all solution versions. So let's look at the equation first, which is 2 times cosine squared of theta minus 2 times sine squared of theta plus 1 equal to 0. Okay, so we have both cosine and sine, and we do not want to having just like both trig values. We want to reducing them into maybe like one trig values. Yes, I can rewriting cosine squared theta into like a 1 minus sine squared theta and solving from that point. But here, since the title is using a double angle formula reverse, so I'm going to using the double angle formula. So the double angle formula says if I have cosine of 2a equals to cosine squared of a minus sine squared of a, where I pretty much have very similar one except both are multiplied by 2. So first I'm going to factor out the 2 and got 2 times cosine squared of theta minus sine squared of theta plus 1 equal to 0. Now I can replace cosine squared theta minus sine squared theta into cosine of 2 theta plus 1. Solving for cosine of 2 theta, and I got cosine of 2 theta equals to negative 1/2. Okay. So that tells me 2 theta have reference angle of using the degree form 60 degree, but because it's negative, so it's in quadrant 2 and quadrant 3. Okay, and another thing I need to point it out on the side is so here is my question A. So I want to find theta over the interval 0 to 360. So theta is between 0 degree and 360. Then 2 theta is multiplied by 2. So it's between 0 and 720. So keep that in mind. When I go to find the, when I go to say that 2 theta is in quadrant 2, my 2 theta can equals to 120, which is in 1 revolution 0 to 360, and also can equals to 120 plus 360, which is 2 revolution between 360 to 720. Then 2 theta will equals to 60, and 2 theta will equals to 480, theta will equals to 240. In quadrant 3, 2 theta can equals to 180 plus 60, 240, and also can equals to 240 plus 360. So theta will equals to 120, and 2 theta will equals to 600, and theta will equal to 300. So in over the interval 0 to 360, theta can equals to either 60, 120, 240, or 360 to make the original question true. Okay, so now I'm going to looking at my second part B. I want to find O solution. So I'm going to continue from 2 theta have a reference angle of 60 in quadrant 2 and quadrant 3. So 2 theta has reference angle of 60 in quadrant 2 and quadrant 3. So that means in quadrant 2, my 2 theta will equals to 60. But because we're talking about cosine, so have a period of 2 pi, so 60 plus 2 pi k. In quadrant 3, 2 theta will equals, in quadrant 2, my 2 theta is going to be 120 plus 2 pi k. In quadrant 3, 2 theta will equals to 240 plus 2 pi k. Now theta will equals to, divided by 2, 60 plus pi k. And in quadrant 3, theta will equals to 120 plus pi k. I'm going to changing the pi to 180 since everything is in the degree form. So 120 plus 360 times k divided by 2 is 180 times k. 360 times k divided by 2, we got 180 times k. Okay, so in general form, for all the solutions, theta is going to be 60 plus 180k or 120 plus 180k, where k is any integer including positive and negative.